Swayam Prabha. Digital India. Educated India.
Welcome to the next big idea. An incredible journey of innovation, passion, and game-changing ideas. Let's see what this team brings to the table.
Good afternoon, judges. This is Ayush Thakur, a student from IIT Madras, currently completed his third year, moving to his fourth year. So what I find in my college is I need to travel a lot of distance each day in my classes, from going from mechanical classes to going to my IT classes. Nearly I travel nearly 5 to 6 kilometers. And this is the case for every colleges like IITs, NITs, Anna universities. We usually travel a lot between the campus. So what I am bringing is an engine which runs on compressed air, rotatory engine. So we can a student can just scan and unlock a vehicle in a rental purpose like 10 rupees, 5 rupees. We have to 5 rupees for an hour, and he can travel a distance like usually our engine give a mileage of like 20 kilometers and a speed below 25 kilometer per hour. So he not even need a license, RC, that thing. So we can just implement it. So like a student can travel a lot of distance in a cycle and need not walk. And this we can implement in colleges, and we can even implement in factories like Hyundai, TVS, Mahindra and Mahindra, those companies. We usually walk a lot between the companies. So this is my model. Future, maybe once we increase the mileage of this engine which runs on compressed air, we can implement in the roads like going between the cities and all. Like I feel this is a better alternative for a EV because EV has lithium-ion batteries, and extraction of lithium-ion costs a lot of carbon footprints. It's so dangerous for the environment. It produces a lot of pollution. But our vehicle works on compressed air, which has no pollution. The air which we exhaust, which comes out, is actually lower temperature than the environment. So it has many benefits, I see. Only the thing we need to achieve is we need to increase its RPM. Like we have made a 3D printed it, and we make the compressed air go to it of 30 bars, and we came to know it achieve an RPM of 5,000 RPM. But we need an RPM of like 3,000, 4,000. Once we get that, we may add a gearbox or anything else, a CVT, continuous bell system, transmission. We can increase the RPM, and we can make the engine, make it implement. We can really make it come to the market. That's what I'm saying. It is cost efficient, environmental friendly. It is far better than any alternative like EVs, which is like so demand nowadays in our market. They see EV is a big thing, but I see EV is even not that great. EV produce more pollution than a gasoline powered vehicle because the current produced by it, we use coal mines, coal to produce that current. So EVs are not that great too, and our vehicle is a perfect alternative for it. We even has brought many great things into it, like pneumatic system, and this is our competitors basically. This is our price and environmental friendly chart, where you can see Aether and Ola Electric are actually high price, but they're not that environmental friendly compared to us. And this side, the bottom one, our vehicle is priceless and environmental friendly, and there are some other air vehicles, but they have not implemented it. They actually failed. O2 Pursuit actually failed. So this is where our product falls. And we have used pneumatics and many system. IoT we have implemented. There is a dashboard which we made, where a person need not have we will not give a dashboard for saving money. The person will use his own phone, has speedometer, light to know what is the mileage, how much compressed air is there in your tank, or can be known from an app. So we even cut cost there. We not give a analog speedometer or anything there. These are target audience, as I said, environment, micro mobility, and in-campus distance. And this is our market size which we calculated. We see that 920 million bikes sold, two-wheelers sold in India, but that's not our target audience. Not even the EV, which is 13.5 million. Our audience for the first year will be just 0.01 million people, which we say. And we are just trying to make a 5% possibility of 5% penetration, which we think that in first year we can generate of 2.5 crores revenue. That's what we are expecting. Just the sale of 500 cycles in India. That's what our first year aim is. This is our timeline which we went.
Okay. I just want to know what is the cylinder capacity that you use to make sure the air you compressed and stored.
So we are just going for now a normal scuba diving tank, which is 6.8 liters. User one made of aluminum of thickness of 8 millimeter, which can withstand a bar of actually 140 bar so, but we are just keeping 30 bar. That's almost good. Like future we may
With 6 liters of air, how
6.8
much?
liters.
6.8 liters of air. How much kilometer you can travel
We are getting a mileage of 20 kilometers.
per liter
No, total.
total?
Total.
So
6.8
then you are not you shouldn't tell it's a mileage of 20 kilometers.
Oh yes, sorry.
Overall, you can once I charge it, then I can go for 20 kilometers.
20 kilometers. Sir. Like in 6.8 you can get
So what is the time it takes to refill it?
Refill it, it won't take a lot of time, sir. Like it is the same thing which our tires we fill, right, in our car.
See, tire capacity will not
Yeah,
even be.
it's less. Like this will take nearly like 10 minutes, 5 minutes, 10 minutes. That's it.
It resembles like turbocharger means. Then I just have one question: is turbochargers are least efficient? You know that?
Yeah, in case of cars, yeah.
Not
But
in
in case of this flights,
even in flights, the engine they don't use turbocharger. They use
superchargers.
superchargers. Okay, and especially in flight, it's completely different because the suction of air is plenty over there, and they are not limited with air.
Yeah.
And over you, it is limited with whatever the capacity that you're giving.
Yeah.
And if there is a least efficiency happening, and if you're not able to pass through it, or if you're not able to control it, and how do you control the speed, like variables?
So we have made a throttle like system, sir. Like
Okay.
if you increase your throttle,
The more air inlet will
flow
be
of air
coming.
increase.
Okay. So how you reduce it? You have brakes.
Yeah, you have brakes, and once you leave your throttle, the flow will get reduced.
No. What is the problem with turbocharger is,
So
see,
this is looking like that.
yeah. Whatever the system looks like a turbocharger means, it has an inlet and it has an outlet, right? Obviously, what happens is it will start to feel like self-sustaining itself. So it will suck air more from the cylinder if you don't stop it.
Yeah,
You get the point, right?
Yeah, I get it.
At particular point, the engine starts to self-sustain by sucking the air and pushing out the air will be like more or less same in RPM. Like you'll have a single propeller connecting to the front and back, right? Like
Yeah,
the single channel propeller, right? Okay, so then the same issue will come for you.
Yeah, so we are working on it, sir. We are making lot of design. First, we make the piston design, sir. Like we are making like accelerator motion to rotatory motion, like
Yeah, it's in the POC stage. Fine.
Yeah.
Good.
good state.
You see, mainly it is you need to concentrate on the dynamics of the air. Okay, so you do.
We are doing CFD, sir.
Yeah, you have to more concentrate on the dynamics and the drag potential. Drag coefficient will be very important. For instance, if it's just a two-wheeler, okay, so your drag will not be that much. But think you have a vehicle weight which has 6.8 liters of air, and then a big cylinder which contains more weight. Again, it has a motor, wheel. Empty vehicle can push a lot, but when it goes to this kind of systems, no, when you add more weight, its efficiency will reduce.
So we even plan like we will have a cylinder made of carbon fiber, but we don't know whether it will withstand
The problem is compressed air 30 bar. If it blasts, then the person is gone. Okay, so you can't compromise with
Then
safety.
we can sell the product to others.
Yeah. So you don't need to look into that angle. But
Like, we need lot of things to do. I do.
yeah, you just do the research work. Fine. Good.
What will be the total cost of your production?
It's coming for us like 30,000, sir.
30,000.
Like we have just calculated. We have not made it completely. We have made only the engine.
So if there is any leakage in the motors, like if there is any there's a cut in a gasket or something, I just want you to like indicate some thing like so that the people could know that there is some leakage in the motor, so that they could like at the start the kilometers will be like it will be telling a kilometers that it will be going for 20 kilometers, but if it's a leakage, the vehicle will be stopping by 10 kilometers. So at the middle, people find difficult for the compressors to fill all those things. So I just want in the future product to implement some necessary steps that the air is not leaked. Okay. Thank you.
And now it's time for judges' opinion about the pitch. You folks are rock stars. Keep it up.